Good morning, dear students. My name is Ferhan Mazher, and today is 15th April 2022. Right now, I am with the 11th Cambridge class, and the subject we are studying is Physics 5054. Today, we have set our hearts to solve a theory paper, and we have selected May June 2015 2 paper. This paper belongs from the zone 2. Today, in this session, in this video, we are going to attempt the section B of this paper. The section A of this paper we have already done, and you can find that video in this same playlist. So let's start today's paper. The section B of this paper we are going to attempt. So let's start. Okay. So you can see the section B of the May June 2015 2 paper is showing up on the screen, and we will be solving this starting from the question number 9. So it says the figure 9.1 shows the wavefronts of a water wave in deep water in a ripple tank. So here you can see wavefronts 1, 2, 3, 4, 5. So basically count how many gaps are there. So this is 1 wave, 2 wave, 3 wave, 4 waves. So there are 4 waves in 6 centimeters. The question is the frequency of the wave in the deep water is 5 hertz. Explain what is meant by the frequency of a wave. You know, the frequency is a 2 marks question. The frequency of a wave means the number of waves passing from a point in unit time. This is known as the frequency. So let me show you my written answer. So question number 9, sorry for this. Okay. So the number of complete waves passing from a point in unit time, that is known as the frequency. Okay, so let's go to the next question. Determine the wavelength of a wave in deep water. So we have to find out. So you can see in 6 centimeters, there are 1, 2, 3, 4. So in 6 centimeters, there are 4 waves. So which means if you divide 6 with 4, you will get the length of one wave, and that is the wavelength. So 6 centimeter divided by 4, and that will give you the wavelength. So 6 centimeter divided by 4, and that will be 3 by 2, that will be 1.5 centimeter. So the wavelength is 1.5 centimeter. Then the second part of the question number 9, B part, is calculate the speed of the wave in the deep water. You know the wave equation, V equals to F lambda. We want to find out the speed of the wave. F is the frequency, which is 5 hertz, and lambda is 1.5 centimeter. So your answer will be 7.5 centimeter per second. Here, remember one thing, that if the lambda is in centimeters, so when you find the velocity, it will be in centimeter per second. If the wavelength or the lambda is in meters, and you calculate the velocity, the unit of the velocity will be meter per second. Because here the wavelength was in centimeters, that's why the speed will be centimeter per second. So let's check the answer. Okay, so this is the marking scheme. We are going to the question number 9. Sorry for this. Okay. So you can see 7.5, 1.5 centimeter, and the definition of the wave. So we are done with the question number 9, A and B part. Okay, then he says the wave passes from the deep water into shallow water. The speed of the wave is less in the shallow water. State and explain how this affects the wavelength of the wave. So this can be explained by 2 methods. So try to understand both the methods. You know, when the water wave will go from the deep water into the shallow water, the frequency do not change. And you know the frequency is equals to V divided by lambda. So the frequency is not changing, frequency will remain constant, and frequency is equals to V by lambda. So if the V value will decrease, the lambda value also has to be decreased to get the same frequency. So if the V decreases, the lambda also decreases, because the frequency is supposed to remain constant. And so the ratio of the velocity and the wavelength, if you want its answer to be the same, if the velocity will decrease, the wavelength will also decrease, so that the frequency is constant. This is one method. Another description can be that the frequency is not changing, the speed of the wave has decreased. Now, when the speed of the wave has decreased, so in the same time period, when the frequency will not change, the time period of the wave will not change. So now, because the wave has the speed has decreased, now in the same time period, the wave will cover less distance. So the wavelength will decrease because the speed is less. So in the same time period, the wave will cover less distance. So the wavelength will decrease. So these are the two methods by which you can explain this phenomena. The wavelength will decrease is basic answer. Okay, so we are going to check what my written. In the shallow water, wavelength is smaller, frequency remains constant. Frequency is the ratio of velocity and wavelength. So if velocity decreases, wavelength also decreases to get the same ratio. I hope you understand. So let's have a look at the marking scheme. Marking scheme says 1 mark for saying that the wavelength will decrease, and 1 mark for saying that the travels at a shorter distance in the same time, or frequency stays the same because V is equals to F lambda. Our answers are right. Okay. He says the wave in the deep water shown in the figure 9.2 travels towards the right and enters the shallow water at an angle. The wave refracts. Refract means it will change its direction. On the figure 9.2, draw the wavefronts in the shallow water. Okay, it's a 3 marks question and a very, very important question. So let's have a look at how we do this. So first of all, with the help of the set square, I will draw the direction line. Basically, the direction line means the direction of the wavefronts in the deep water. The direction line, you can see I'm using a set square to draw the direction line. And here is the direction line. This is the direction line. This shows the direction of the wave. And this is perpendicular to the wavefronts. You can see the angle here to the wavefronts, it is of 90 degrees. So this blue line basically tell you the direction of the wavefronts in the deep water. So where this direction line touch this boundary between the deep water and the shallow water, at this point, I will place a protector. The crosshair of the protector is at that point, and both the zeros are on that boundary. Now I will put a dot of 90 degrees because I want to draw a normal to this boundary. So put a dot here and then join it with the boundary, and that will be the normal. So here you can see I have drawn the normal. So when the waves will enter into the from the deep water into the shallow water, and we know that the speed of the water wave will decrease. So whenever the wave speed decreases, the wave bends towards the normal. So in the shallow water, the direction of the wave, which I have represented with this blue line, it will bend towards the normal. So you can see this, I have drawn this. This is the normal, and this is the direction line. Now I will place a protector on the direction line in the shallow water, and this is the 90-degree mark and this crosshair, they both are on this direction line. And I will move this edge in such a way that this edge coincides somewhere with this wavefront. When this first wavefront touches the boundary, so the straight edge of this protector is also coinciding with that point. And here I will draw that line. So here, then I will move the protector further. Now this crosshair and the 90-degree mark, they both are on this direction line. And when this straight edge of the protector coincides with this second wavefront, when this wavefront touches the boundary, this straight edge is coinciding with that point, I will draw a line here. So that will be my, and I will continue doing this process. And you can see I have shown here these three wavefronts. You can see that these wavefronts are parallel to each other. They are perpendicular to the direction line in the shallow water. Plus, these wavefronts are closer to each other, which shows that the wavelength has decreased. So this is a very, very important question. I hope you have understood the technique. Okay, so that was the question number 9 and C and its second part. So I hope you understand. Then his question is, let me show you the marking scheme and then we go. So the marking scheme is showing up. So let me show you the marking scheme. These are wrong. These are the wrongs. This one is the right. This one is perfect. So our answer is also same. This one is right. Okay. Describe one difference between a sound wave and a water wave. You know, the sound waves, they are longitudinal waves, and they comprise of compressions and rarefactions. Whereas the water waves are transverse waves, and they comprise of crust and trough. So that's the basic difference. And in the sound wave, the particles of the medium through which the sound travels, they vibrate parallel to the direction of the wave. And in the water wave, the particles of the medium through which the wave travels, they vibrate perpendicular to the direction of the wave. So these are the two famous differences we have only mentioned here. So this is the answer, and you can write any one of them, okay? One row only. So these are the, you can pause the video, you can read them, and you only have to write one of the differences. Okay. Let me show you my written answer. I have not shown it. So sound waves are longitudinal waves, and in them medium particles vibrate parallel to wave, whereas water waves are transverse and particles of its medium vibrate perpendicular to the direction of the wave. Hopefully you understand. Then the next question. It's a 3-mark question. He says the speed of sound in carbon dioxide gas is less than the speed of sound in air. Using this information or otherwise, describe an experiment to show the refraction of the sound waves. You may include a diagram of your apparatus. It's a 3-mark question. So let me show you. So here you can see I have shown a speaker. Here we have a mic, and this mic is attached with the CRO, and we will produce a sound from the speaker, and the mic will catch that sound, and the CRO will make the waveform of that sound. Then between the speaker and the mic, we put a balloon which is filled with the carbon dioxide, and you produce the same sound. But when the same sound is produced, this time you will observe, you will have the same wave, but the amplitude of this wave will be larger. This means that when the sound waves have passed through the carbon dioxide, they have refracted. That's why the amplitude or the loudness of the sound has increased. So note the wave formed on the CRO of the sound produced by a speaker without anything between speaker and the mic. Then put a balloon of carbon dioxide between speaker and the mic. wave on the CRO will show a change in amplitude. This shows refraction of the sound took place in CO2. Hopefully you understand. He says method of generating sound, for example, loudspeaker and signal generator, 1 mark for this. Apparatus that enables refraction, clear, for example, carbon dioxide in balloon or any shape where refraction is possible. Method of detecting refraction, for example, microphone, and how it is used to show the refraction, the loudness will increase. Okay, so we are done with the question number 9. So let's go to the next question. Figure 10.1 shows a relay connected to a cell and a switch. So when the switch S is closed, the iron core is magnetized. The left side of the core is an north pole, as shown in the figure 10.1. The iron armature is attracted to the core on the figure. It says on the figure 10.1, mark the south pole of the iron core, the north pole and the south pole of the iron armature. So here a south pole will appear, here a north pole, and here a south pole. It's a 2 marks question. So let me show you. So you can see here we will have a south pole, north pole, and south pole. It says the cell is reversed. State what happens to the poles and to the armature. You see, when you will reverse the cell, when you will reverse this cell, the north will appear here and the south will appear here. And when the north will be here, here automatically a south will appear. And the iron armature still will be attracted to this end of the electromagnet. So that is my answer. Let me check. Polarity of the iron armature will also reverse. Lower end will become south and the upper end will become north. And the iron armature vertical portion will be still attracted to the right side of that solenoid. Then the question is, explain why the core is made of iron and not steel. We made it for the iron because the iron is a soft magnetic material. It will be easily magnetized. And when you will stop the current in the solenoid or the coil, the iron will immediately lose its magnetism. But this is not the case with the steel. Once the steel is magnetized, and when you switch off the current, the steel will not lose its magnetism. It will retain its magnetic properties for a long time. So iron is a soft magnetic material. When switch S will open, iron core will lose its magnetic properties. But the steel will retain its magnetic properties for a longer time. So here you can see the answer is showing up: south pole on the right of the core, north pole anywhere on the vertical section of the armature, and south pole anywhere on the horizontal section of the armature, or north pole on the left of the vertical section of the armature and south on the right. Poles on the core reverse, change position, armature still attracted to the core. This sentence is very important. The armature will be still attracted to the core. Iron is a temporary magnet, or iron easily demagnetized, or steel retain magnetism. When current off, no battery, switch off, circuit open, and armature released, does not stay attracted, open connections. Okay. Figure 10.2 shows the relay connected in a circuit to a 12-volt battery. The bell is not ringing. State the name of the component X. This is the symbol for a thermistor. This is the circuit symbol for a thermistor. So X is basically a thermistor. Explain why the bell rings when the temperature of X rises. So when the temperature will rise, the resistors of the thermistor will decrease, and here the current will start flowing. And when the large amount of current will flow through this branch, this coil will become a stronger electromagnet and it will attract this toggle towards the left, and this switch will be closed. When this switch AB will be closed, and the path of the current for this bell will be completed and this bell will start ringing. So the name of the component is thermistor. Resistance of thermistor will decrease, so larger current will flow through the coil. It will become stronger magnet and it will close the switch of the relay. When the resistance of X is 2000 ohm, the current in the coil is 1.5 milliampere. This causes the contacts in the relay to close. The resistance of the bell is 200 ohm. Calculate the potential difference across the X. You know the current flowing through the X, and you know the resistance of the X. So very easily we can find the potential difference. V is equals to IR. They are talking about this X. We know its resistance 2000 ohm. We know the current flowing from here, and that is how much? 1.5 milliampere. So very easily we can find. Let me show you the numerical which I have done. So V is equals to the voltage drop across the X will be V equals to IR. I is 1.5 X per minus 3 because it's milliampere. So that in amperes it will be 1.5 X per minus 3. And the resistance is 2000 ohms. So V equals to IR. Just multiply them and you will get 3 volt. So the voltage drop across the thermistor will be 3 volt. Then the question is the potential difference across the coil in, because that branch is parallel to the battery. The voltage of the battery is 12 volts. So in that branch, the total voltage drop will be 12. So the voltage drop across the X is 3, and the total voltage drop on that and on that branch is supposed to be 12. So the voltage drop across the coil will be 12 minus 3, and that will be 9 volt. So let's have a look at the marking scheme. Three volt and 9 volt is our answer. So this answer is right. So you can have a look at this answers. So let's go to the next part. Then the question is find the current in the battery. Okay. So the current coming from, if you know the current flowing through the other branch, and you know the current flowing through the first branch, so we can find the total current. So I need to find out how much is the current flowing here. Here the voltage drop will be 12 volt, and if I know the current flowing from here, I can find the current in that branch. And then I will add up all the current, add up the current in both the branches. So the current along the bell will be the voltage across the bell divided by the resistance of the bell. That will be 12 volt divided by 200 ohm, and that will be 0.06 ampere. And in milliamperes, it will be 60 milliampere. So the total current coming from the battery will be the current in the first branch and the current in the second branch. And that will be 1.5 milliampere plus 60 milliampere. So it will be 61.5 milliampere, approximately 62 milliampere. 62 milliampere. So let's have a look at the marking scheme. So our answer is right, sir. You can see this answer here. Okay. Component X is removed from the circuit and replaced by a different component Y. The bell now rings when the bright light shines on the Y. So state the name of the component whose resistance changes by the by the brightness of the light, and that is light dependent resistor LDR. Yeah, LDR is the right answer, sir. So our answers are right. A bungee jumper falls from a bridge above a river as shown in the figure 11.1. So this is the position A at the top. He's standing at the top. Position B, he's coming down, but the cord is still loose. Position C, the cord starts to stretch. The position C, the cord, this bungee starts to stretch. And position D, he's at the lowest point, and after this, he will go back due to the elasticity of that bungee cord. The man starts from the position A in the figure 11.1. The elastic cord starts to stretch at position C and stops for the first time at the position D. He continues to rise and fall. Okay. So figure 11.2 shows how the velocity of the man varies with the speed, with the time, sorry. So here the velocity is represented, here the time is represented. So the question is, state what is meant by velocity. Velocity is basically the rate of change of the displacement. The rate of change of the displacement is known as velocity. So have a look at the marking scheme. So our answer is right. Then state the difference between a positive velocity and a negative velocity. Positive velocity and a negative velocity means the direction. So if you are going, for example, they are coming downward, that is positive, and when he will go upward, that will be the negative velocity. The moment of the amount of velocity at that moment will be negative when you are going upward. When you're coming downward, your speed is decreasing, increasing, whatever. But if you are coming downward, it is a positive velocity. So let me check the answer. Positive velocity means body is going down. Negative velocity means the body is going upward. This word is going, okay. In the figure, in the first 1.4 seconds, the acceleration is uniform. Using values from the figure 11.2, determine the acceleration of the man in the first 1.4 seconds. We can apply the formula of the gradient. So we have taken 2 points from the figure 11.2, 0, 0 and 1, 10. So I will find the m, that will be y2 minus y1 divided by x2 minus x1. So 10 minus 0 divided by 1 minus 0. So it will be 10 meter per second square. That will be the gradient. And so the gradient is equal to the acceleration, and that is 10 meter per second square. So our answer is right. Comment on your value of the acceleration, because our value is 10 meter per second square, and that is the exact value of the acceleration due to the gravity. Then the fourth part, he says, state the value of the T when the man is at the position D. So it will happen at T equals to 4. At D, you see this, they are asking about this question. What is the D? When the body will start, its direction of the motion will change. So it is here. When the direction of the velocity will change. So at T equals to 4, this will happen. Then their question is plain in terms of the forces acting. Why the man is accelerating upwards at the D? You see, at the position D, you see at the position D, the cord is fully stretched, and now there is restoring force in that cord, and that force will bring that body upward. That force has become greater than its weight. Weight is acting downward, so there is an upward force, resultant upward force, and in the influence of that upward force, resultant force, the body will go in the upward direction. The tension is the elastic, the tension in the, sorry, this is the tension in the elastic cord is in the upward direction and is more than the weight of the man. So the resultant force is in the upward direction. Figure 11.3 shows the values for the gravitational potential energy of the man, the kinetic energy of the man, and the elastic potential energy in the cord at A, C, and D. You may ignore the effect of air resistance in this position. So in the position A, the gravitational potential energy is 20,000, kinetic energy is 0, elastic potential energy is also 0, and the total energy of the system is 20,000 joules. Then at the position C, there is some gravitational potential energy still present, that is 15,000 joules. And we know that elastic potential energy is 0, and so the kinetic energy will be also 0. No, so it will be 5,000, because this is 15,000 and the 5,000, the sum should be 20,000. The total energy of the system do not change. Okay, so let me show you from here. So the at the position C, the potential energy will be 15,000, and the rest of the 5,000 will go to the into the kinetic energy, and the elastic potential energy is still 0. At the position D, when the gravitational potential energy will become 0, the kinetic energy will become 0, and the elastic potential energy will be 20,000 ohm. Okay. Our answer was 4 seconds. Yeah, the answer is right. So the marking scheme is showing up on your screen. You can pause the video and you can take your time, read this marking scheme. Then he says the man has a mass of 50 kilogram. The gravitational field strength G is 10 Newton per kg. Using the values from the 11.3, calculate the vertical distance between A and C. So at A, the gravitational potential energy is 20,000, and at C, the gravitational potential energy is 15,000. It means that the 5,000 energy has converted into something, any other thing. Okay. So the mgh will be, because the difference of the gravitational potential energy is 5,000. So mgh is equal to 5,000. So m is 250 kg and the g is 10. So h will be 5,000 divided by 50 divided by 10. It will be 10 meters. It means that c is 10 meters below the a. Let's check the answer. So our answers are right. So my dear students, we are done with this paper. So, my dear students, we are done with the May, June, and 2015 Physics 505422 paper. Today, in this video, in this session, we have done the section B of this paper. So, thank you very much, everybody. I hope this video will help you. It will help you to improve your answering skills, and it will make your life easier. If you think that this video has helped you, it has improved your answering skills, please subscribe my channel and also share the link of this video onto your Facebook and onto your Instagram and onto your Twitter accounts. So thank you very much. It's a great pleasure for me to teach you online. Have a good day. God bless you.